Can you hear me? Is it audible to you?
Yes, ma'am.
Okay, no, thank you. So good morning, all. Only 40 people have joined, I think. What about the rest? Can I check out your friends whether they have joined or not? Ask them to join immediately. Quick. Still 8 more have to join. என்னக்கா? எப்ப? Okay. So, what about other exams? Have you all attended? All are attending the exam properly at the correct time? Any issues? Can I am asking you only. எக்ஸாம்ஸ் எல்லாம் கரெக்டாக அட்டன் பண்ணுறீங்களா? டைமுக்கு அட்டன் பண்ணுறீங்களா?
Yes, ma'am.
Yes, ma'am.
Okay. So if you have any issues in uploading, எதுனாலுமே வந்துட்டு you can communicate. Okay. Because MCQs மட்டும் you have to upload it by sharp 1:30. Okay.
தேனி பூச்சி தானே மேம் நான் இங்க வரேன் சேதி இப்படி கைவிட்டு எடுக்கிறேன் ஒரு பூச்சி
Okay, so then I think we have stopped here. We have stopped at I think whether we have discussed this interrupts, the type of interrupts. Do you remember whether we have discussed? I think we have discussed what is an interrupt. The basic introduction I have given. Have we seen this hardware interrupt and software interrupt? Anybody do remember what was the concept we have seen in the last week? I think so. Just refer your notebook and let me know whether we have completed it or not. Quick, make it fast. Just look at your notebook. Have we completed the type of interrupts? Balasurya, are you there?
Yes, ma'am. ஹார்ட்வேர் இன்டரப்ட் சாஃப்ட்வேர் இன்டரப்ட் பார்த்துட்டோம் மேம். அதுக்கப்புறம் டெய்ஸி செயின் ப்ரியாரிட்டின்னு திங் மேம், அதை எடுத்துட்டு இருந்தீங்க.
அந்த டயக்ராம் கம்ப்ளீட் பண்ணமா? இல்ல கண்ணா, டெய்ஸி செயின்
டயக்ராம் டெய்ஸி செயின் சொன்னீங்க மேம், அதுக்கப்புறம் எடுக்கல மேம்.
ஓகே கண்ணா, ஓகே, தேங்க் யூ. சரிம்மா, so we'll start from there. So one of the priority it is daisy chaining priority. Okay. So see, interrupt is nothing but actually it is a signal, isn't it? It is a signal in order to interrupt the CPU. When the peripheral needs the attention of the CPU, immediately the peripheral will issue an interrupt to the CPU. Okay, through which it can send the signal. It can satisfy its need actually. Suppose if a printer is ready, or if your keyboard is ready, and if your keyboard wants to give an input to the CPU, isn't it? So in such a case, the CPU will be busy in some other task, right? So now my keyboard will interrupt the CPU saying that I need the attention of CPU. So please give me your attention so that I can complete my work. So if any peripheral wants to disturb the CPU, wants to gain the attention of the CPU, it will issue a signal, and that signal is nothing but your interrupt signal. So interrupt is nothing but it is a signal which is issued by the peripheral devices in order to gain the attention of the CPU. Is it clear? அப்போ CPU வந்து CPUக்கு நிறைய works இருக்கும். CPU வந்து do multitasking. You all know what is multitasking. So CPU will be busy executing in many tasks simultaneously, right? So இப்போ ஏதாவது ஒரு peripheral ரெடியா இருக்கு அப்படின்னா what your CPU does, your peripheral will gain the attention of the CPU. அப்படி attention நமக்கு வேணும் அப்படின்னா அப்போ வந்து இந்த peripheral போய் CPU disturb பண்ணும். And that disturbance is nothing but the interrupt signal. Okay. So in that interrupt only, we have discussed about the priority interrupt. So priority in the sense it is nothing but the importance which is given. That is dealt with the priority. Say for example, if two or three peripherals, more than one peripheral is waiting for the same time. That is simultaneously they are waiting. Like my printer is ready, my magnetic disk is ready, my keyboard is also ready. So all these are my peripheral devices. All are my peripheral devices, and they need the attention of the CPU at the same time. So now the CPU will get confused. No, so to whom I can give my attention? To which device I need to give my attention? Whether I have to look after the printer or the keyboard or the magnetic disk. So that sort of confusion can be resolved with the help of this priority interrupt. So which device carries the highest priority among the three? So what are the three I told you? Like printer, magnetic disk, and keyboard. Your disk always carries the highest priority. Always your disk carries the highest priority. Next comes your printer, and at last comes your keyboard. Right. So which device carries the highest priority? Your CPU will give attention to that particular device alone, and that sort of technique, which is otherwise known as priority interrupt. Okay, so interrupt can be generated by all your peripheral devices. All the peripheral devices can generate the interrupt, but the thing is, to which device the CPU has to give attention. That is decided based on the priority. That is decided based on the priority. Okay, so under this priority interrupt, you can see two different types of mechanism are available to deal with this priority interrupt. Okay, and the first one is your daisy chaining priority. So I'm not going to read all these points. I'll just explain you in the diagram itself. Okay, so that it is very, you can take the screenshot of this. It will be very useful for you to write the theory. So I'm not going to read out all these things. We'll directly get into the diagram of daisy chaining priority because these are very, very important techniques. Okay, so whenever you are asked to write about the priority interrupts, you're asked to write about the priority interrupt, you need to write about both the techniques. You need to mention the daisy chain priority and your parallel priority. These are the two techniques that was in your syllabus also. So we will also discuss these two techniques. Okay. So please listen to the class. What are all the questions? What are all the topics we are revising today, which are taking today, will be there in the question paper also. Okay, so please listen to the class and also take notes. Parallelly draw the diagram and just write down the hints. Right? Just write down the important points. Merely taking the screenshot will never help you. Okay, running notes, important points, note பண்ணா மட்டும்தான் you can get into the concept very clearly. Fine, right. So first we'll deal with this daisy chaining priority. Okay, just look at the diagram. See, I'll highlight it for you. See, these are the devices. Say I have these are the devices, kind of like device. See, I have device one, device two, and device three. Okay, so all these devices are nothing but your peripherals. All these devices are called as your peripherals. Okay, you know what is peripheral devices? All the input output devices. What are all the devices you are connecting to the computer? What are all the devices that are connected to the computer or otherwise called as peripheral devices? Okay. See, after completing these two techniques, I'll ask you questions also. You need to explain the architecture. Okay, because we have 1.5 hours time. So definitely after completing this daisy chain and parallel priority interrupt, I'll ask you a question. Okay, so please listen to the class. Okay, so here we have three peripherals that are attached to the CPU. See here, fine. So what I'm coming to say is, I told you that peripherals can get the attention of the CPU just by issuing an interrupt signal that you all know very well. So in the peripherals, the CPU attention வேணும்னாலும் it has to issue a signal, and that signal is called as what? Interrupt. So interrupt is nothing but it is a signal. Right. Now there are three peripherals, and all the peripherals are ready. All the peripherals need the attention of the CPU. Okay. So what I can do, I need to, if in this technique, according to this daisy chaining technique, I need to arrange all the peripherals in the chain manner. I need to arrange all the peripherals in a chaining order. That is, see, device 1, 2, and 3. In which order I need to arrange? That is the second question. Okay, ma'am, you told me that all the three devices are ready. In the மூணு device you வந்துட்டு sequential arrange பண்ணணும்னு சொன்னீங்க. In which order we need to arrange? We have to arrange in such a way that the highest priority device should occupy the first position. So say for example here device 1. The device 1 is nothing but my magnetic disk. Okay, and the device 2 is my printer. and the device 3 is nothing but my keyboard. Yeah. So all the three devices are arranged sequential manner, and while arrangement of the devices, what you have to do, you have to place the highest priority device in the first position, followed by the second highest, and followed by the third highest. Okay, so this is how the device should be arranged in a sequential manner. That is the first point in this architecture. And the second thing, now what I told you that all the devices are ready and they need the attention of the CPU. Obviously, which device will get the attention of the CPU at the first time? Only the device which carries the highest priority will get the attention of the CPU. All the other devices will never receive the attention of the CPU unless or otherwise this first device has completed its task. So device 1 அதோட டாஸ்க் முடிச்சா மட்டும்தான் அடுத்த டிவைஸ்க்கு அது இம்பார்ட்டன்ஸே கொடுக்கும். Because my device 1 has the highest priority, அதான் விஐபி மாதிரி. ஸோ நான் விஐபி அவங்களோட டாஸ்க் எல்லாம் சர்வ் பண்ணி முடிச்சதுக்கு அப்புறம் தான் ஐ மூவ் டு த நெக்ஸ்ட் டிவைஸ். அந்த மாதிரி ஞாபகம் வச்சுக்கோ. தட் இஸ் ப்ரையாரிட்டி. நவ் டிவைஸ் 1 ஓகே. இப்போ வந்து சே ஃபார் எக்ஸாம்பிள் டிவைஸ் 1 இன்டரப்ட் இருக்கு அப்படிங்கிறது சிபியூக்கு how it just make the CPU to recognize that I'm sending a signal. There is a line which is called as your interrupt request line. Okay, you have a line which is called as what? Interrupt request line. This interrupt request line will always be in a high impedance state. It will be always in a high impedance state, but if on the line low out, then any of the device issue an interrupt signal. Okay, when any one of the device issue an interrupt signal, at that point of time, that particular line will become low. Your interrupt request line, at that point of time, your interrupt request line will become low. Now, is it clear? Can you hear me now? Can you hear me?
Yes, ma'am.
Okay. Can you see the screen? Can you view the screen? Is it visible?
Yes,
No,
ma'am.
ma'am. Yes,
It
ma'am.
is visible. One is saying
Yes, ma'am.
is okay. Okay, ma'am. Okay. Yeah. Yeah, we were discussing about this daisy chaining priority, isn't it? So I told you that all the devices should be arranged in a sequential order, and provided the highest priority device will occupy the first position. The device with the highest priority will occupy the first position, followed by the second, and followed by the last. Okay, least priority device. This is how the device will be arranged in a sequential order. And how the device will get the attention of the CPU? It will get the attention of the CPU by sending a signal which is called as interrupt, which is otherwise called as interrupt. So, see, I have highlighted a line over here. See, in this diagram, this is called as your interrupt request line. This is called what? Interrupt request line. And this particular line will always be high. this particular line will always be in a high impedance state. I have already discussed you what is high impedance state, isn't it? When we are discussing about that strop control mechanism and handshaking mechanism, I told you what is high impedance state. Similarly, here also the interrupt request line will always be in a high impedance state. And suppose if any one of the device issue an interrupt signal, if any one of the device issue an interrupt signal, at that time this particular line will become low. Okay, say for example, see if line will become low, this particular line will become low. Now the CPU comes to know with this line. When the line becomes low, immediately the CPU recognizes it. எப்பவுமே ஹை இருக்கும்போது திடீர்னு லோ ஆகுது அப்படின்னா immediately your CPU will identify that. Okay, so now your CPU will recognize that this particular line has become low. So if some of the device have generated an interrupt. So immediately your CPU will recognize that. After recognizing that the interrupt is being generated by a device, the CPU has to acknowledge now. CPU வந்து ஓகே நான் உங்களுக்கு வந்து என்ன பண்றேன்னா உங்க ரெக்வஸ்ட் சாட்டிஸ்ஃபை பண்றேன்னு சொல்லணும். அதான் acknowledgement. You know what is acknowledgement, isn't it? So once the CPU comes to know that a particular one is your interrupt request line, another one is your interrupt acknowledge line. Okay, so the interrupt request line will be used. The interrupt device and the interrupt acknowledged line will be given by the CPU. Right? So now, see, I told you that device 1 has generated an interrupt, isn't it? So device 1 has generated an interrupt immediately. Immediately what happens, Kana? Immediately your interrupt request line will go low. Okay, it goes low. Fine. After that, what the CPU comes to know, okay, some device has generated the interrupt. That is by having this PI. Now immediately your CPU, okay, it will act. And this acknowledgement follows a chaining method. This acknowledgement follows the chaining method. I'll explain you in the next step. Now, once the CPU has acknowledged, the value of PI becomes 1. See here you have PI and PO. Okay. PI is 1 and PO is 0. The value of PI is 1 and PO becomes 0. Okay, so if PI is equal to 1, which means the CPU has acknowledged the interrupt. What is the meaning for that? The CPU has acknowledged the interrupt. And what is PO equal to 0? PO is equal to 0 means it is blocked by the particular device 1. CPU attention, the device 1 means நான் block பண்ணி வச்சிருக்கேன். I will not give the attention of the CPU to other device. That shows PO is equal to 0. So for every device, we have PI and PO. For every device, we have PI and PO. PI equal to 1 means what does it mean? The CPU has given the acknowledgement to device 1. The CPU has given the acknowledgement to device 1. That is called PI is equal to 1. And PO will be immediately set to 0. Immediately set to 0 means what does it mean? If it's set to 0, it means that device 1 has blocked the attention of the CPU. Device 1 has blocked the CPU. It will not give the CPU to others. Device 1 என்ன சொல்லுதுன்னா I need the attention of CPU. எனக்கு CPU வேணும், so I'm going to block it அப்படின்னு அர்த்தம். So PO will be set as 0 and PI is equal to 1 at any point of time in the first case. Okay. First case என்ன பார்த்திருக்கோம்? In the first case, device 1 has generated an interrupt. In the first case, device 1 has generated an interrupt, and when the device
Ma'am,
has
your voice is very low, ma'am. It's not clear, ma'am.
it's very low.
Yes, ma'am. It's
Can't
too
hear
low,
you.
ma'am.
Ma'am, lagging too much, ma'am.
It's getting lag also, ma'am.
Wait, I'll connect it with my internet itself. Maybe in the college network it will be some delay. Wait, I'll do it. சத்தமா பேசினா நமக்கு உள்ளுக்குள்ளே எப்போ ஆகும்? Can you hear me now? Is it okay? Can you hear my voice now?
Yes, ma'am.
Still, is it low? Is it audible?
Yes, ma'am.
Okay, ma'am. Okay. Yeah. Okay, ma'am. So, what is the point is your device one has generated an interrupt. Once it generates an interrupt, immediately your interrupt request line will go low. From that, your CPU recognize that okay, that one of the device has generated an interrupt. It comes to know that one of the devices has generated an interrupt. Immediately, the CPU has to acknowledge, and for acknowledgement, it uses another line which is called as interrupt acknowledge line. It uses another line which is called as interrupt acknowledge line. Once it sends the interrupt acknowledge line, see, once it sends this interrupt acknowledge line, your PI, see here you have PI, P input and P output. Okay, PI means P input, PO means P output. Once the CPU sends the acknowledgement, the value of PI will become 1 because acknowledgement வந்துருச்சு இல்லையா, வர வரைக்கும் 0 இருக்கும். Acknowledgement வந்துருச்சுன்னா it becomes 1 and PO will become 0. The value of PO will become 0. I'll tell you why PO is 0. PO is 0 because here my device 1 has blocked the attention of the CPU. My device is not ready to give the CPU to other devices. Okay, my device is not ready to leave the attention of the CPU to other device. So your PO is 0. Your PI is 1 because my device has received the acknowledgement from the CPU. My device has received the acknowledgement from the CPU, right? So that's all about this PI and PO. Now, after everything is over, now CPU can inform பண்ணியாச்சு. My highest priority device has informed the CPU that, okay, see, I'm ready. So please give me your attention. அதுக்கு CPU என்ன பண்ணிச்சு? Acknowledgement கொடுத்துருச்சு. Okay, I'll give the attention to you. அப்படின்றது acknowledgement. Fine. After doing all of these things, now the CPU has to come to this interrupt service routine. இதெல்லாம் முதல்ல நான் சொல்லியிருக்கேன் ISR. For every interrupt generated, there is a subprogram which is called ISR. ISR stands for interrupt service routine. So your CPU has to execute that function. For every interrupt generated, your CPU will need to execute that function. On the function எங்க இருக்கு, you need the address of that program. For everything is stored inside the memory, and for every line there is an address in the memory. Okay, each and every word is stored in the memory, and for every word there is an address. Address இல்லாம you can't fetch anything inside the memory. So you need an address. If the CPU wants to move to the particular location, it needs the address. Without the address, the CPU cannot move from one location to another location. Okay, so it needs the address specifically. So now the device comes to know, okay, device has generated an interrupt, CPU has acknowledged. Now what is the role of the device? Now the device has to mention its address. Okay, நீ எனக்கு acknowledge பண்ணிட்டேன், நான் வரேன்னு சொல்லிட்டு நான் உங்ககிட்ட கேட்குறேன், I am asking for your permission. You have given me the permission. Okay, you have granted me the permission. Immediately what I have to do, I need to give my address, then only you can come to my location. No, so immediately my device will place the address, that is called vector address, VAD. See here in this architecture you have a name which is called VAD. VAD stands for vector address. So what is the vector address actually meant for? The vector address is nothing but the address of that interrupt service routine. ஒரு இன்டரப்ட் வந்திருக்கு, அப்போ CPU எந்த லொக்கேஷனுக்கு போனால் அந்த சர்வீஸ் ரூட்டினை எக்ஸிக்யூட் பண்ண முடியும்னு தெரியும். ஸோ அந்த லொக்கேஷனோட அட்ரஸ் தான் இங்கே நான் வெக்டார் அட்ரஸ்ன்னு சொல்கிறேன். ஓகே, ஸோ VAD is nothing but your vector address. Okay, so now the point is, now இதுக்கு ஏன் daisy chain பேர் வந்து, why the name daisy chain comes here? Because not only because all the devices are connected in a serial way, one after the other, like the pipelining. இதோட input அதோட output அப்படி கனெக்ட் ஆனனால மட்டும் கிடையாது. The reason why this particular architecture is called daisy chain now, I'll discuss you with the second case. See, first case what we have discussed. In the first case, device 1 has the highest priority in zone. Okay, fine. Now, say for example, device 2 has generated the interrupt. Device 1 illa, now we are discussing case 2. What about case 2? In case 2, device 2 has generated an interrupt. Okay. What is the first step that is taken? Immediately my interrupt request line will go low. Okay. It becomes low. Fine. So now my CPU comes to know. My CPU comes to know that the interrupt is generated. What is the role of the CPU now? The CPU has to respond to me. No, now interrupt signal அனுப்பிச்சிருக்கேன்னா the signal நீ respond பண்ணணும்ல. And that response is nothing but the interrupt acknowledged line. Okay. And now I tell you, this interrupt acknowledged line will not be directly sent to device 2. Device 2 தான் generate பண்ணுச்சு. அது CPU க்கும் தெரியும். The CPU also knows that device 2 has generated an interrupt, but acknowledgement will not be directly given to device 2. நல்லா புரிஞ்சுக்கோ. The acknowledgement will not directly sent to device 2. It will be sent via device 1. Device 1 வழியாக தான் acknowledgement போகும். Okay. So now device 1 க்கு ஏன்னா I told you that it is a priority interrupt concept. What do you mean by priority interrupt? Only the device with the highest priority will seek the attention of the CPU at very first time. At all times, your CPU will check the higher priority device and then only it moves to the lower priority. Whether the higher priority device ready இருக்கா இல்லையான்றது matter கிடையாது. That is the concept over here. Okay, so your CPU will always checks for the higher priority device. அதுக்கிட்ட interrupt இருக்கா, அதுக்கு ஏதாவது நம்ம attention வேணுமா அப்படின்னு check பண்ணி பார்ப்போம். And then only it comes to know, okay, now higher priority அதுக்கிட்ட interrupt இல்லை, it does not need my attention. Okay, I'll move. Daisy chaining architecture, because all the devices are connected via chain, and the acknowledgement will also be passed from one chain to the next. You'll be passing the acknowledgement from one chain to next. So your CPU will send the acknowledgement to device 1. Your CPU will send. Now my CPU comes to know that the device 1 has no interrupt at all. It has no interrupt at all. Immediately, my PO will become 1. My PO will become 1. If PO becomes 1, then the acknowledgement will be passed to device 2. Only if PO becomes 1, the acknowledgement will be passed to device 2. Now device 2 will receive the attention of the CPU. Now only device 2 will receive the attention of the CPU. So your acknowledgement line is a single line. Your acknowledgement is a single line, and it passes from the higher priority device to the lower priority devices. Okay. Only if the device 1 is not ready, if the device 1 has not generated an interrupt, then only your acknowledgement will move to device 2. Or else what happens? Device 1 லே தான் இருக்கும். Device 1 ல interrupt இருந்ததுன்னா it will satisfy the interrupt and then only it will move to device 2. Okay, so this is how your interrupt acknowledgement will be done, and that's the reason why this architecture is called daisy chaining architecture, because all the devices are connected via a chain. All the devices are connected via a chain. Now, what is the third step? Yeah, I have generated an interrupt. I receive the acknowledgement of the CPU. Immediately, my device has to, what it has to do? Immediately, my device has to give you the address, because the CPU has to move to that location now. How it moves to the location without the address? So immediately, my device will give the address out of it, which is VAD2. That is address of device 2, vector address of device 2. That is called VAD2. Okay, right. So that's all about this hardware priority interrupts, which is connected in a daisy chain architecture. Okay, Kana, any doubt in this? Any doubt in this particular architecture? That's all about daisy chaining. So once you know the architecture, you can write it by yourself. Just draw the diagram and you can write by your own explanation. There is nothing to mug up anything in this. Okay. So any doubt in this daisy chaining priority? Shall we move to the next one? Any doubt in this?
No, ma'am.
See, I'm asking you only. What about others?
No, ma'am.
You are listening or simply
No,
speaking?
ma'am.
Okay, ma'am. Shall we move to the next one? See, I told you that they have two mechanisms. First one is in priority interrupt. The first one is your daisy chaining priority. Okay, and the second one is your parallel priority interrupt. Okay. So now we'll see the second one, which is parallel priority interrupt. Okay, so these things, all these things I have discussed already. If you want, you can take a screenshot of this also. This is about your daisy chaining priority. Okay, I have discussed all these points, so I'm not going to read out this now. At the time of explaining itself, I told you all these things. Okay, so if you want, you take the screenshot or else I'll move the next one. Yeah. So this is your the next concept, the next priority interrupt, which is called as your parallel priority interrupt. Okay. So in this uh, architecture, your parallel priority interrupt. Here, the same pointer, same thing. Now all the devices, see, here also the same thing, but there is a slight difference between daisy chaining and parallel priority interrupt. I'll tell you what it is. See, all the four devices are here. These are called peripheral devices. Okay, all the four devices are called as what? Peripherals. Okay, so what are all the peripherals are here? You have disk, printer, reader, and keyboard. Okay, so all these four peripheral devices are here. And you know the priority. Always your disk carries the highest priority. This is the highest priority. Then comes printer, next reader, and at last comes keyboard. And at last comes keyboard. So this is how the devices are arranged. This is how the devices are arranged. Okay, so all the why it is called as parallel priority interrupt. The reason is now all the devices has generated the interrupt at the same point of time. That is simultaneously all the devices has generated an interrupt. Okay, so here we are maintaining two register actually. One is my interrupt register, another one is your mask register. Masking apnale hiding. I tell you what is the purpose of two registers. Okay, one is your interrupt register, another one is your mask register. And initially, both your interrupt register and your mask register will contain the same value. Say device 0. So my interrupt register carries the value 0 for device 0. For device 1, it carries the value 1. For device 2, it carries the value 2. And for device 3, it carries the value 3. This is my interrupt register. These are the values in my interrupt register. And correspondingly, my mask register will also carries the same value. I told you no. So what are all the values in the interrupt register? The same value will be repeated in the mask register. This is my initial case. To start with, this is what the manufacturing logic what I have. Okay, so now all the four peripherals are ready. Fine. So all the four peripherals are there, and for the devices we have numbered as device 0 to device 3. Okay, and we are maintaining two registers. One is our interrupt register, and the one is our mask register, and the device number is being given to the register. The value of the register, it just simply carries the device number. That's it. Now, now, what is the purpose of this mask register and why do we have this interrupt register? The reason is why we have these two registers. I'll tell you now. First, say for example, if my disk, I have a magnetic disk. Okay, if my disk has generated an interrupt, that is, my disk is ready, my magnetic disk is ready, and it needs the attention of the CPU. It needs to grab the attention of the CPU. So what it has to do? It has to generate a signal, and that signal is nothing but your interrupt, isn't it? So now my magnetic disk is going to generate an interrupt. So whenever, because disk is the highest priority device now, so this occupies the first position always because that has the highest priority. So it occupies the first position in my architecture. So in my disk, correspondingly, the interrupt register value will become 1. Why it becomes 1? Because there in the daisy chaining priority, we have a line actually. We have a separate signal actually. That signal is nothing but your interrupt signal. So if any of the devices has generated an interrupt, immediately your signal will go low. So from that, my CPU will recognize that some of the devices has generated an interrupt. This is the concept in daisy chaining priority. But as far as this parallel priority interrupt is concerned, if suppose any of the devices has generated an interrupt, if any of the devices has generated an interrupt, it will set the interrupt register value as 1. It will set the value as 1. Okay, your interrupt register value will be set as 1. So that is what given in the disk. Your interrupt register value, disk is set as 1. And very important point is all the other values of the register will become 0. All the other values in the register will become 0. Similarly, the role of my mask register is also the same thing. In this mask register also, the first, the disk value will become 1 and all the other values will become 0. So it masks actually. Masking means it hide all the other devices. It always give importance to the higher priority device. Okay, so how it gives importance? By hiding all the other devices, because all the 4 devices have generated an interrupt simultaneously. But according to this parallel priority interrupt concept, only the highest priority device should get the attention of the CPU for the very first time. So what I have to do, I need to hide all the remaining devices. So to hide all the remaining devices, we use a separate register, which is called as your mask register. So by setting the value 0 to the mask register, all these devices will be hidden. All these devices will be hidden, and only the device with the highest priority will get the attention of the CPU. Just a simple logic. Okay, using the mask, எல்லாத்துக்கும் mask போட்டு ஒளிச்சு வச்சிடறேன் அந்த மாதிரி. Using a mask, I'm hiding all the other devices, and I'll always project the device which carries the highest priority. I'll always project the device which carries the highest priority by setting the mask bit as 1. If the mask bit is set as 1 அப்படின்னா, that device is visible. Okay. If the mask bit is set as 0 அப்படின்னா, that device will become invisible. Okay. Masking means hiding. அவ்வளவுதான். Right. So now, just look at this. We have an encoder here. We have an encoder because encoder, it's a 4 by 2 encoder. It receives 4 inputs and it generates only 2 outputs. That is the reason why it is called as 4 by 2 encoder. Okay, so it is a priority encoder. The concept of encoders we have discussed in the earlier classes. So the same concept over here. So why now it is 4 by 2 ketna? I have 4 peripherals over here. Okay. I have 4 peripherals over here. So the disk carries value 0 0. Printer it is 0 1 because four devices in the 2 bit வேணும்னா 2 bits 0 1 2 bits அப்படினா எவ்வளவு காம்பினேஷன் வரும்? I have 4 combinations. So 0 0 0 1 1 0 1 1. Okay, so these are the 4 combinations. These are the 4 combinations, which is 0 0 0 1 1 0 and 1 1. So 0 0 it stands for magnetic disk. 0 1 means printer, 1 0 means reader, 1 1 means keyboard. 1 1 means keyboard. Okay, so I0, I1, I2, I3. So what is this I0? I0 is nothing but 0 0. So I0 is nothing but the value of I0 is 0 0. I1 is 0 1. I2 is 1 0. And I3 is 1 1. I3 is 1 1. Okay. So all the 4 peripherals are ready and all these 4 combinations are used for selecting the peripheral because we need to select the peripheral and it has to given to the CPU. No? So for selecting the peripheral, these are all the indexes that are given. I0, I1, I2 and I3. At any point of time, if I0 is selected, which means disk is selected. What is the meaning for that? The device disk, I0 stands for device, first device 0, which is disk. If I1 is selected in the encoder, if the encoder selects I1, which means the meaning is the printer is selected for the CPU to get the attention of the CPU. If I2 is selected, what is the meaning? My reader has get the attention of the CPU. If I3 is selected by the encoder, the meaning is the keyboard is going to get the attention of the CPU. Okay, so this is what I0, I1, I2 and I3 meant for. So these are given in a priority encoder. So what your encoder does, your encoder has to select one among all the 4 devices. It will select only one. Always your encoder will generate only one output. It will select only one device at any point of time. It will not select more than one devices because I can give the attention of the CPU to only one device at any point of time. Okay, so among this I0, I1, I2 and I3, my encoder is going to select only one device. And that is selected based on the input given to the encoder. See how the input is given to the encoder with the help of the AND gate. So what are the 2 inputs that are given to the AND gate? One input is from the interrupt register. One input is from the interrupt register and the other input is from the mask register. See, now I'll show you how this architecture works. See, I'll put the value here. I told you that my disk, all the four devices, these are peripherals, and all the four devices are operating simultaneously. At any point of time, my disk will carry the highest priority. So my CPU has to give the attention to the disk first. So I'm going to set the disk value as 1 and all the other values as 0. Similarly, what is the purpose of mask register? The mask register has to hide all the other devices and it has to enable only the disk. It has to enable only the disk register. So only the first value will become 1 and all the other values will be 0. And all the other values will be 0. Now see, the first input is one is from the interrupt register and the other one is from the mask register. Interrupt and the mask. Interrupt and the mask. So both are 1. You know, Kana, what is the operation of your AND gate? If both are 1s, your AND gate will generate 1. If both the input are 1, your output of AND gate will be high. So here my both the inputs are high. See, one from the interrupt register and I have one from the mask register. Since both the inputs are high, my output is also going to be high. Right. What about the other thing? See, coming to printer, both the inputs are low, so the output is low. Coming to the reader, both the inputs are low, the output is low. Coming to the keyboard, both the inputs are low, so the output is also low. So now tell me which device is selected. Which device, Kana? Which device is here? Now these things will be given to the encoder. Okay, these things will be given to the encoder. And now tell me which device will be selected according. Your priority encoder. Your priority encoder will select which one? Which one is selected by the priority encoder? Yeah, answer my question. Which device will be selected, Kana?
Disk.
Yeah, it is disk because all the other values are 0. So only disk carries the value 1, which is I naught. Disk is nothing but I naught. So I naught is equal to 1. So whichever is high, that particular thing will be selected by your priority encoder. So my encoder will select appropriately the disk. My encoder will select the disk. And now, what is the value of I naught? I naught is nothing but initially I told you in the truth table 0 0. I naught carry the value 0 0, which is x and y. X and y, because we have to pass it to the bus because we need to get the address of the device now. We need to get the address. So I'm just passing to the bus buffer that x and y are nothing but 0 0. Initially the xy value is 0 0. 0 0 stands for I naught. 0 0 stands for I naught. Okay, this is one particular case. And what is the other output given by your encoder? Your encoder will also generate a flag which is nothing but your interrupt status. That flag is nothing but IST. IST stands for interrupt status. Interrupt status. And IEN is nothing but interrupt enable. Interrupt enable. Both are flag inputs. Okay, both are flag. And if IST is 1, your enable will also be 1. If IST is 0, your enable will also be 0. Okay, at any point of time, both the flag will carry the same input. I'll tell you why. See, here what I told you, IST is nothing but interrupt status and IEN is nothing but interrupt enable. Interrupt status and interrupt enable. Here, actually my priority encoder. Actually, my encoder has generated an interrupt and it also selected the device. So immediately it will send another signal. It will send another signal stating that the interrupt is generated because that has to be sent to the CPU home. அப்பதானே சிபியூக்கு தெரியும் ஓகே சம் டிவைஸ் ஹஸ் ஜெனரேட்டட் அண்ட் இன்டரப்ட் அப்படிங்கிறது சிபியூக்கு எப்படி தெரியும் இட் ஹாஸ் யூ ஹேவ் டு கிவ் அ சிக்னல் நோ ஸோ ஃபார் சென்டிங் அ சிக்னல் டு த சிபியூ யுவர் என்கோடர் வில் கிவ் அவே another output which is a flag output that is nothing but your IST. So immediately your IST will become 1. If your IST will become 1, automatically your IEN, that circuit has to become enabled. Only if there is an interrupt, you will enable the circuit or else you will not enable the circuit. Interrupt இருந்தால் மட்டும்தான் இந்த சர்க்யூட்க்கு வேலையே இருக்கு. So if there is no interrupt, there is no point in enabling the circuit also. Okay. So only if there is an interrupt, then only you have to enable the circuit. So whenever your IST is 1, at that point of time, your IEN will also carry the value 1. Right. If both are 1, see, both the things are given to an AND gate. both the inputs are given to the AND gate. So now the output is high. Since both the inputs are high, the output is high because it is an AND gate. So now an interrupt signal is given to the CPU. This interrupt signal is given to the CPU. See, this is one whole architecture actually. Okay, I'll complete it. Now an interrupt signal is given to the CPU. And as usual, in the daisy chaining also, we have discussed the same. Once the CPU has received an interrupt signal, immediately it has to acknowledge. Okay, immediately it has to acknowledge. So your interrupt acknowledge will be given by the CPU. So the interrupt acknowledge line will be generated from the CPU, and that has to be given to the AND gate, and that has to be given to the AND gate, and the signal has to be enabled. Your interrupt status is also enabled. Immediately your circuit will be enabled because all are high. Acknowledgement is there, interrupt status is high, your interrupt enable is high. This AND gate will receive all the three inputs, and since all the three inputs are high, the output is also high. So I'm going to enable the circuit. I'm going to enable the circuit. Once it is enabled, this bus buffer, once it is enabled, this bus buffer, it has to immediately send the vector address of the device. So once it is enabled, your device comes to know that, okay, CPU has going to respond. CPU is ready and it is going to respond to me. Okay, CPU is ready and it is going to respond to me. So immediately what it has to do? Immediately, this particular I0, the device I0 is ready. The device I0, what it has to do? So now the CPU is ready now. So the device I0 has to give away the address, which is called as your vector address. I told you, no, it has to give away the vector address because without the because it has to give away the vector address. Okay. Okay, ma'am. So yeah, so once the device is ready, it has to give away the address, which is called as the vector address. So the vector address of the device I0, the vector address of the device I0 is given to the CPU. Because without the address, the CPU cannot jump to that location. It cannot execute that interrupt service routine. It cannot execute that interrupt service routine. No. So now I0 has to issue this address, and this is nothing but your vector address. See, this is your vector address. And this vector address of I0 is given to the CPU. Now the CPU will process the interrupt. Now the CPU will process the interrupt. Okay, so that's all about the whole architecture of your parallel priority interrupt. And this is very important question. Okay, regarding this priority interrupt, in many question papers, they have asked this particular question, which is parallel priority interrupt in 5 mark also. Okay, specifically they have asked this parallel priority interrupt. In some question papers, they have asked generally, they have asked you to discuss on priority interrupts. In such a case, you can write about both your daisy chaining priority and parallel priority. ரெண்டையுமே எழுதலாம். But specifically, if they ask this parallel priority interrupt, now you have to write what is an interrupt, and you have to directly draw the architecture, and you need to explain every point. Each and every point is very important. Okay. So this is how your interrupt is generated. For case 1, I have let you know all the concepts, how your encoder works, what is the role of the bus buffer, what is IST and IEN. IST means interrupt status flag, IEN means interrupt enable flag. Whenever your interrupt status is 1, at that point only your interrupt is enable will also be 1. If your interrupt status is 0, your interrupt enable will also be 0. Okay, IST 1 இருக்கும்போது மட்டும்தான் IEN 1 இருக்கும். Because interrupt இருந்தால் மட்டும்தான் your circuit will be enabled. Your circuit will be in an active state. Okay, only if there is an interrupt, then only your circuit will be in an active state. Okay, just look at this diagram once again. I'll give you 2 minutes time. If you have any doubts, ask me. I'll repeat the architecture or else we'll move further. Okay, just look at this. Any doubt in this parallel priority interrupt architecture? Do you have any doubt? If you want me to repeat now, I'll repeat once again. Yes?
No, ma'am.
No doubts. What about others? Parthiban, Ponkanan, are you there in the meet? Parthiban, can you hear me? Parthiban? Unmute your voice. Sanjana, are you there? Sanjana? Sanjana, can you hear me? Sanjana is not there. See, after I'm taking the attendance, if you are not responding, I can't give you the attendance because in the software some of your names are not appearing. So I need to take the attendance manually. So you need to say yes or no. Otherwise, I can't give you attendance also.
Yes, answer attendance, Abhinesh. Abhinesh.
Abhishek, are you there? Abhishek? Abhishek, can you hear me?
Telamil.
Aditya,
Dhanush.
Yes, ma'am.
Akshaya,
Dhanush. Gautam.
Ma'am. Yes, ma'am.
Aditya, Akshaya.
Present, ma'am.
Yes, ma'am.
I'm here, ma'am.
Present.
Dhanush.
Yeah, okay, Kanna. Okay. Akshaya is
Present.
there. Okay. Okay. Alfin.
Present, ma'am.
Okay, Akshaya. Alfin.
Present, ma'am.
Anu Akash.
Present, ma'am.
Okay. Ashif. Ashif.
Manjuna. Okay, Abhinesh.
Ashif.
Lalita absent. Manjuna.
Ashif is not there. Ashif present. Okay, ma. Okay. Ashwin.
Navastri.
Present, ma'am.
Ashwin. Yeah.
Naveen.
Balasurya.
Yes, ma'am.
Nisan.
Harnipriya.
Pavitra.
Present, ma'am.
Harita.
Prithviraj.
Present, ma'am.
Rakesh.
Kalimuddin.
Rakesh. Rahul.
Present, ma'am.
Kumar.
Okay. Karpsami.
Ramkumar.
Karpsami, are you there?
Present.
Can you hear me or not?
Reshma.
Okay. Karpsami absent.
Harihasan.
Physically not present. Krunal.
Absent. Sanjay.
Present, ma'am.
Lohit.
Sanjay.
Yes, ma'am.
Sanjay absent. Santosh.
Mahendra Verma.
Andus.
Okay, ma.
Saravakumar.
Sri Manu Sabarishwaran.
Saravakumar. Satyanarayan.
Sabarishwaran.
Sylvia.
Can you hear me or not?
Soundarya K. Soundarya M.
See, if you are not answering the attendance, no, sorry, I can't give you the attendance, ma.
Okay, okay. Yes, Prasan.
Manya.
Present, ma'am.
Okay, ma'am. Again, also the
Harris.
join the meet by
Present, ma'am.
Mona.
Present, ma'am.
okay, Sylvia.
Present, ma'am.
Mona.
And
Yeah.
then
Present, ma'am.
Java programming, totally talking students that are not yet
Okay, Kana. Maulish.
I will give time to you. Right?
Present, ma'am.
Yes, Rahul.
Okay.
Abhinesh,
Naiza.
Arunkasar,
Present, ma'am.
Abhinesh, Bharat,
Naiza.
Chandramouli,
Present, ma'am.
Dhanush,
Nija.
not yet taken.
Present, ma'am.
Then
Yeah.
Hemalata, Infant,
Noel Raj.
Yes, Infant.
Present, ma'am.
Ponkannan.
Did you take the seminar?
Ponkannan.
Infant Arogya Raj.
Can you hear me? Ponkannan.
Yes, okay. I think interface concept, right?
See, still class is not over.
And then Karthik V.
Okay. Till 11:30 there is a class, but in between I'm just taking the attendance only. I didn't ask you to leave the meet. One or two has left the meet.
Prasan,
Akshaya is not there. Akshaya has left the meet.
Kumar, Saida Sen,
What is she doing?
Sanjay, Santosh, Saravanan Kumar, sorry, not
Parthiban.
and Vijay.
Ma'am, he has some mic problem.
So எல்லாரும் prepare பண்ணி
Okay, why can't you send message kana at least? இவ்வளோ நேரம் கூப்பிடுறாங்களே ஒரு மெசேஜ் அனுப்பலாம் கூட தெரியாது.
எடுத்தீங்கன்னா
ஆ? சும்மா டைம் இல்லாம வேலை இல்லாம கூப்பிட்டு இருப்பாங்க.
சரியா?
பொன்கண்ணன்
இப்போ absent is there.
2 பேருக்கு ஆப்ஷன்.
Okay, thank you.
பிரகாஷ்,
Thank you all.
Present, ma'am.
பிரவீன்,
Present, ma'am.
பிரீத்தி,
Okay.
Present, ma'am.
So all the
ராஜேஷ்,
Present, ma'am.
ராஜ்குமார்,
Ma'am.
Pranita,
Present, ma'am.
ரேஷ்மா,
Present, ma'am.
சமந்தா,
Present, ma'am.
சஞ்சனா.
Present, ma'am.
சஞ்சனா அப்ப இதுக்கு முன்னாடி கூப்பிட்டப்ப ஏன் ரெஸ்பாண்ட் பண்ணல சஞ்சனா?
Ma'am, there is no network, ma'am. So only, ma'am. Now only friends messaged me, ma'am. Ma'am called you.
ஓகே then, ஓகே. சஞ்சனா வர்ஷினி,
Present, ma'am.
சஞ்சய்,
Present, ma'am.
ஓகே. சந்தோஷ்,
Yes, ma'am.
சர்மா,
Present, ma'am.
ஷரான்,
Present, ma'am.
ஸ்ரீவர்ஷினி,
Present, ma'am.
சுந்தர், சுஷாந்த்
Present.
and Vindhya.
Present, ma'am.
Ma'am, Kingsley present, ma'am.
Okay, Kanan. Now tell me. Kingsley, உன் நேமே இங்க வரலையே. இடையில மீட்ல இருந்து வெளிய போறியா?
Network issue, ma'am.
Kingsley,
Network issue, ma'am.
okay. Okay, Kana. So, regarding this parallel priority interrupt, Kana, if you want me to repeat now, I'll repeat once again. என்ன பண்ணலாம்? Shall I repeat or shall we move to the next one? No time சொல்லணும்னா I'll repeat the architecture because it is very important. ஏதாவது கொஸ்டின் கேட்டா மட்டும் யாரும் வாய் திறக்க மாட்டீங்க. கொஸ்டின் கூட கேட்கல. வாட் ஐ வாண்ட் யூ வாண்ட் மீ டு டு தான் கேக்குறேன்.
மேம் இதுல எனேபிள் கடைசில 1 வேல்யூ போயிரும் மேம். அது பஸ் பஃபர் ஏதாவது வேல்யூ சேஞ்ச் பண்ணுமா மேம்?
இல்ல கண்ணா, ஆக்சுவலி சி எனேபிள் இது வந்து பஸ் பஃபர் ஏன் எனேபிள் பண்ணுதுன்னா பிகாஸ் ஃபர்ஸ்ட் வந்து ஒரு இன்டரப்ட் சிக்னலை வந்து நம்ம சிபியூக்கு அனுப்பிச்சிடணும். சிபியூக்கு அனுப்பிச்சதுக்கு அப்புறம் சிபியூ வந்து ரெஸ்பாண்ட் பண்ணணும் வித் ஹெல்ப் ஆஃப் அன் அக்னாலஜ்மெண்ட். ஸோ இப்போ சிபியூ வந்து இந்த லைன் பாருங்க, நான் ஹைலைட் பண்றேன். CPU வந்து it will give the acknowledgement to the AND gate. Okay, right. Acknowledgement line போடையும் your interrupt லைனும் போகும், உன்னோட enable லைனும் சேர்ந்து போகுது, அவ்வளவுதான். Because interrupt இருந்தா தான் acknowledgement போகணும், அது ஒரு இன்னொரு டைம் ensure பண்ணிக்குது, அவ்வளவுதான். So there is an interrupt. Only if there is an interrupt, your interrupt status line will be one, your interrupt enable line will be one, right? So interrupt இருந்ததுன்னா இது ரெண்டும் சேர்ந்து CPU க்கு ஒரு interrupt signal அனுப்பிச்சிடும். Because both are one. So ரெண்டுமே சேர்ந்து interrupt signal CPU க்கு போய் சேர்ந்துடும். So once the CPU has received an interrupt signal, it has to acknowledge. So your interrupt acknowledge line will be given to the CPU. அது வந்து டைரக்டா interrupt acknowledgement line வந்து டைரக்டா சர்க்யூட் போகாது. interrupt acknowledgement வரும்போது CPU செக் பண்ணி பார்க்கும், மறுபடியுமே சர்க்யூட் வந்து ஆக்டிவா இருக்கா, சர்க்யூட்ல வந்து interrupt இருக்கான்றது இன்னொரு டைம் செக் பண்ணும். So for that only another input is given, which is your interrupt status and interrupt enable. Because that is going to be one at all times, because there is an interrupt and still it is not being serviced. Okay, it is in the pending state only. So still the interrupt is serviced by the CPU, both the flag will be set to 1. Okay, so your IST will also be 1, your IEN will also be 1. Now your interrupt acknowledgement line will also be 1. See, if all the 3 lines are 1, your enable is 1. Only if this is enabled, only if it is enabled, your bus buffer receives the signal from the CPU, and now your bus buffer should be ready to give the address of that particular device to the CPU. இது enable பண்ணதுக்கு அப்புறம் தான் you'll get the address. If your bus buffer is not enabled அப்படின்னா it will not give the address of the device, of the corresponding device which has generated the interrupt. So if it is not enabled என்னாகும், your device will assume that okay நம்ம interrupt request pass பண்ணிட்டோம் but CPU has not responded அப்படின்னு அர்த்தம். பஸ் பஃபர் எனேபிள் ஆயிருச்சு அப்படின்னா ஓகே நம்ம அனுப்பிச்ச இன்டரப்ட்க்கு CPU என்ன பண்ணிடுச்சு, CPU has sent the acknowledgement அர்த்தம். Okay, so only if you receive the acknowledgement, your bus buffer will be enabled. So if the bus buffer becomes enabled, now the device comes to know, now the CPU is ready to give the attention to me. So immediately நம்ம device என்ன பண்ணணும், அட்ரஸ் கொடுத்தா தானே CPU will process பண்ணணும், it needs the address. So immediately my device will give the address. And that address will be given to the CPU, which is nothing but VAD. VAD is nothing but your vector address. VAD is nothing but your vector address. And this vector address will be sent to the CPU. Okay, so the vector address எப்போ அனுப்பும்ன்றதா பாயிண்டிங். எப்போ அனுப்பும்? After receiving the acknowledgement from the CPU. After the device has received the acknowledgement from the CPU, then only it will send the vector address to the CPU. So what is the next step? Once the CPU receives the vector address, already இப்போ நான் இங்க ஒரு சர்க்யூட் போடுறேன் பாரு. Here I have the main program. Actually my CPU வந்து இந்த இடத்துல எக்ஸிக்யூட் ஆயிட்டு இருந்தது. இந்த லைன் எக்ஸிக்யூட் பண்ண ஒரு இன்டரப்ட் உள்ள வருது. ஓகே, ஒரு இன்டரப்ட் உள்ள வருது. இந்த இன்டரப்ட்க்கு என்னோட CPU ரெஸ்பாண்ட் பண்ணுது with the help of an acknowledgement. Okay, immediately after receiving the acknowledgement, இந்த டிவைஸ் என்ன சொல்லுது, இந்த அட்ரஸ்க்கு வாங்க சொல்லி சொல்லும். Immediately my CPU will jump to that address, that vector address. அங்க ஒரு ப்ரோக்ராம் எழுதி வச்சிருக்கோம், and that is called ISR, which is your interrupt service routine. Now your CPU will fully execute this function. This ISR will be executed by the CPU, and then only your CPU will come back to the normal program. The CPU will come back to the normal program and it will execute that normal program. Okay, so இப்படிதான் interrupt வந்து இடையில ஒரு disturbance line வந்தா it will move to that, it will acknowledge it, it will move to that routine, it will complete that routine, and then it will get back to its original work. Then only your CPU will get back to its original work. Fine. So yeah, yes, Balasurya, do you understand now? And enable எப்படி எதுக்கு ஒண்ணா இருக்குதுன்னு?
Yes ma'am, yes ma'am.
What about others? Any other doubts? Can I வேற யாருக்காவது doubt இருக்கா? You want me to repeat or shall we move to the next one? Prakash? Prakash, can you hear me? Prakash?
Ma'am.
Attendance. பிரகாஷ் லிசன் பண்ணிட்டு இருக்கியா? லிசன் பண்ணிட்டு இருக்கியா, என்ன வேலை பார்த்துட்டு இருக்கியா?
லிசன் பண்றேன் மேம்.
என்ன டாபிக் ஹெட்டிங் என்ன சொல்லு? என்ன டாபிக் எடுத்துட்டு இருக்கோம்? Tell me the heading. ஸ்கிரீன்ல இருக்கு பாரு. உனக்கு ஸ்கிரீன் மொபைல் ஸ்கிரீன்ல தெரியுமா? எங்க பிரகாஷ் காணாம போயிட்டியா? பிரகாஷ் விஷயம் கேட்டா ஓடி போயிடும். Okay, ma. So, do anybody have any other doubts on this? Shall we move to the next one? Reshma Chandran.
Ma'am. Yes, ma'am.
Another doubt இருக்கமா? The architecture parallel priority. சொல்லுமா?
No doubts, ma'am.
Is
No
it
doubt.
okay? Is it understandable?
Yes, ma'am.
Okay. Okay, Kanak. So if you are asked about the interrupts now, you have to write about the interrupt, and you need to write about priority interrupt. Then you have to mention your daisy chaining priority, and then comes your parallel priority interrupt. But specifically, if they ask you to write about any one of the interrupt, you can draw this architecture and you can explain all the points clearly. Okay, fine. So now interrupt is over. That particular topic is over. Now we move on to the next one. Yeah, actually, this table is also very important. I have drawn the table over there, but it will not be very clear, I think so. You please take a screenshot of this table also, Kanam. Okay, so because we have seen that priority encoder, no? You know how encoder works. We have already seen the operation of the encoder. The same truth table is also given here with respect to all the four devices what we have seen in the architecture previously. So here, see, but you have to draw the truth table also for this priority encoder. Okay, you should not miss this. So I'll explain this truth table once again for you. You know that when more than one interrupt takes place, always what is the job of your priority encoder? Your priority encoder will select one among the devices which carries the highest priority. Say for example, if two devices have generated the interrupt at the same time. Generated. Now, what your priority encoder has to do? Your priority encoder has to select one of the device which carries the highest priority. So your priority encoder, what it does, it will select only the magnetic disk, isn't it? It will select only the magnetic disk. It will not care about the printer because magnetic disk is the highest priority. So that is the job of the priority encoder. It will always select the highest priority interrupt. Right. So now what are all the inputs? I told you that we have four devices, ma'am, which is magnetic disk, which is I0, and I1 printer, I2 is reader, and I3 is keyboard. Whatever you can have anything. So all the four devices are here. See now, if the first device, see, if the magnetic disk has input 1, what do you mean by that? My first priority, my magnetic disk has generated an interrupt. Once your disk has generated an interrupt, it will not take care about all your priority encoder will don't care about all the three devices. ஏன்னா ஃபர்ஸ்ட் விஐபி இருக்கும்போது மற்றவங்களை பத்தி கன்சிடரே பண்ண மாட்டாங்க, இருக்கா இல்லையான்னு கூட பார்க்க மாட்டாங்க. அதான் டோன்ட் கேர் கண்டிஷன். So my first priority goes to my magnetic disk. Since my magnetic disk has generated an interrupt, my encoder will not look into all the other devices. அடுத்து என்ன டிவைஸ்னு கூட பார்க்காது because this carries the highest priority, no. So அடுத்து இருந்தாலும் இல்லைனாலும் I'm not going to do anything. I'm going to serve only this particular device only. So all the things, all the other devices we don't care. Whether it generates an interrupt or it has not generated an interrupt, I don't care about it. That's D. So D stands for don't care. Okay. And the next one, when I1 is 1, the device I2 and I3 carries lesser priority when compared to I1. I1 compare பண்ணும்போது your I2 and I3 will carry lesser priority. So that is don't care. Even I2 generates an interrupt, I will not care about it. So that is don't care. And when I2 is 1, I will not care about I3 because I3 carries the lesser priority. And when I3 is 1, this is the last case. If I3 ki எப்போ வந்து you get the CPU attention, only if all the above devices has not generated an interrupt. மற்ற எந்த டிவைஸுமே இன்டரப்டை ஜென்ரேட் பண்ணாத டைம்ல தான் your I3 will get the attention of the CPU because it carries the least priority. Okay. So in the last case, all are zero. All are zero. There is no interrupt at all. Interrupt all devices they are busy in their works. They do not need the attention of the CPU at all. So in such a case, the value will be zero for all the four devices. Okay, all the devices. Look at the table. All the four devices are zero. So obviously, what about the output? So here X and Y don't care because none of the devices have generated an interrupt. So X and Y obviously it is don't care. And very important thing is your interrupt status flag. See, if there is no interrupt, obviously my IST will be zero. I told you only if there is an interrupt, your IST will be 1. If there is no interrupt and the flag will then interrupt and circuit active, so it becomes your status will become 0. IST will become 0. In all the other cases, your IST is 1. In all the other cases, your IST is 1. And what is the output? If I0 is selected, the output is 0, 0. Device 0, 0 is selected. If I1 generated an interrupt, device 0, 1 is selected. If I2 generated an interrupt, 1, 0 is selected. If I3 generated an input, 1, 1 is selected. Because I told you that if I have 4 devices, I0, I1, I2, and I3, the corresponding device numbers combinations are 0, 0, 0, 1, 1, 0, and 1, 1. 1, 0, and 1, 1. Okay, so that is what given at the output. And I told you what is IST. IST is your interrupt status flag. Only if there is an interrupt, your IST will be 1. If there is no interrupt, your IST will be 0. And the Boolean function. They have also returned the Boolean function. This is written using KMAP actually. This is written using KMAP. It is not necessary for us. நமக்கு இந்த இன்புட் அவுட்புட் மட்டும் எழுதி ப்ரியாரிட்டி என்கோடர் போட்டாலே போதும். ஈவன் இஃப் இட் இஸ் எசென்ஷியல்னாலும் யூ கேன் ஈஸிலி அண்டர்ஸ்டாண்ட். இதில் ஒன்றும் பெரிய கஷ்டம்லாம் இல்லை. எக்ஸ் இனிஷியலி சி எக்ஸ் இஸ் 0 0. Both I0 and I1, I0 dash, I1 dash, because both are 0 0. அதனால I0 dash, I1 dash. We have used SOP form. And for Y, 0 1 na kanna I0 dash I1 plus 0 0 I0 dash. That is 0 0 I0 dash I2 dash. அது எடுத்துருக்கோம். So obviously your interrupt status flag IST, your interrupt status flag IST will be OR combination. Because if any one of the interrupt is 1, my IST will be 1. ஏதாவது ஒன்று ஒன்றா இருந்தால் கூட போதும்னு சொல்லும்போது I use an OR gate. So I used a plus symbol over here. So I0 plus I1 plus I2 plus I3. If any one of my interrupt is generated, my IST will be high. So I have used an OR gate over here. Okay, so this is about a Boolean function, but it is not essential for you. You can strip it off. You can write only in the truth table. You can write this input and output alone. Yes. So this is the truth table of your priority encoder. This is the truth table of priority encoder. Fine. Right. Then shall we move to the next one?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am. So the next very important topic is your DMA. Okay, direct memory access. This is very, very important, and in many of the question papers, this particular question is asked under 10 mark actually. So either they'll ask you to draw the block diagram of DMA controller. So nearly 5 to 6 question papers I have come across this question. DFA la in the question illada question paper illennu kuda solluvom. That much important this particular concept plays a role over here. So just direct memory access. So before getting into this, these slides, these important points, I'll give you a quite simple diagram where you can understand the concept very easily. அதுக்கப்புறம் essay எழுதுறது, I mean theory எழுதுறது it will be easy for you. Okay, see, I'll tell you what it is. So first, yeah, I have a peripherals. Okay, so this is the peripheral, right? So I have DMA over here. Okay, and this is the memory, and this is the CPU. There are components actually. All are here. Okay, all are here. Now, this is my peripheral devices. Either device, any IO devices. Okay, simply I'm referring it as peripheral. This is my memory. This is my DMA controller. C means controller, and this is the CPU. Okay, Rana? Fine. Now, what is the role of this DMA? DMA na enna? D stands for direct, M for memory, A for access. So, from the word, the meaning is very clear that we are going to access the memory directly. That's direct memory access. I'm going to access the memory directly. எல்லாரும் memory directly தான் access பண்ணுவாங்க. இதே புதுசா ஒரு டெக்னிக் டிஎம்ஏ கொடுத்துருக்காங்க அப்படின்னா no one will access the memory directly. Everyone will need the attention of the CPU. CPU இல்லாம எந்த வேலையுமே நடக்காது. நான் முதல்ல இருந்தே உங்களுக்கு அதான் சொல்லிட்டே இருக்கேன். Because CPU is the core of the computer system. It is the heart of our computer system. Without CPU, none of the process will take place. எந்த வேலையுமே நகர்த்த கூட முடியாது. நமக்கு எப்படி பிரெயின் இல்லாம நம்மளால எந்த ஒரு ஆக்ஷனுமே பண்ண முடியாதோ அதே மாதிரிதான் நம்ம கம்ப்யூட்டர்ல CPU தான் பிரெயின் ஆக்சுவலா. அது இல்லாம நீ எந்த வேலையும் பண்ண முடியாது. பட் ஸ்டில் ஒரு சில வேலையை மட்டும் அக்காம்ப்ளிஷ் பண்ண முடியும்னு சொல்லி ப்ரூவ் பண்ணியிருக்காங்க த்ரூ திஸ் மெக்கானிசம். அதுல ஒண்ணுதான் டைரக்ட் மெமரி ஆக்சஸ். டைரக்ட் மெமரி ஆக்சஸ் எதுக்கு வருது? இந்த கண்ட்ரோலரோட வேலை என்னன்னு கேட்டீங்கன்னா, பிகாஸ் இன் சம் கேசஸ் யுவர் ஐஓ டிவைசஸ் நீட் டு கம்யூனிகேட் வித் மெமரி டைரக்ட்லி. ஐஓ டிவைசஸ்னா நம்ம பெரிஃபரல்ஸுக்கு மெமரியில இருக்கிற டேட்டாவை எடுக்கணும், போடணும்னு தோணும். ஸோ யுவர் பெரிஃபரல்ஸ் ஹாஸ் டு கம்யூனிகேட் வித் மெமரி, அண்ட் யுவர் மெமரி in turn can communicate with the peripherals directly bypassing the CPU. Bypass பண்றது என்னது? அதை விட்டுட்டு without the attention of the CPU. So without the attention of the CPU, I must do the communication between the peripheral and the memory. Okay, your peripheral device has to communicate with the memory device, but without the attention of the CPU. அது எப்படிமா முடியும்? CPU தான் பிரெயின், அதான் கோர் அப்படிங்கிறது. அது எப்படி முடியும்னா, yes, that is possible. possible with the help of a controller, with the help of a hardware. Actually, DMA controller is a hardware. Okay. So with the help of a hardware which is called DMA controller. ஸோ இப்போ இந்த டேரெக்டாக ஒயர் கனெக்ஷன் எல்லாம் போகாது மெமரிக்கு பெரிஃபரல்ஸ். ஓகே, உங்களுக்கு புரியறதுக்காக நான் இப்படி போட்டேன். பட் ஆக்சுவலி வாட் ஹேப்பன்ஸ் இஸ் actually your see your peripheral will communicate with DMA and your DMA will communicate with memory. Okay, so your peripheral will send some data. எதை அனுப்பணுமோ it will send the data to the DMA. First DMA கிட்ட ரெக்வஸ்ட் வாங்கும், DMA ஓகே சொல்லும், அதுக்கப்புறம் டேட்டா அனுப்பும், DMAவும் மெமரி கூட கம்யூனிகேட் பண்ணும். Similarly, memory will communicate and the data will be given to the peripheral. So the ரெண்டு பேருக்கு நடுவுல it acts like a bridge. Your DMA controller will act like a bridge between which two devices, between your peripheral and the memory, between the peripheral and the memory. Okay, and now okay, so what we are discussing, yeah. So your peripheral, in some cases, without the attention of the CPU, ஏன்னா எல்லாத்துக்குமே if you want to grab the attention of the CPU, நம்ம யோசிச்சோம் அப்படின்னா CPU will be wasting a lot of time actually, because IO devices will be very bitterly slow, but CPU will be very fast. இப்போ IO device வந்து மெமரி கூட கம்யூனிகேட் பண்ணணும்னா CPU நடுவில் உட்கார வச்சிருக்கும். So CPU மூலமாக தான் it will communicate with the memory. So at that time your CPU will be idle for most of the time. It will be wasting its time. So in order to utilize the CPU, in order to utilize it more efficiently, இந்த DMAC அதுக்காக தான் கொண்டு வந்தாங்க. It is cost effective, but still அது இருந்தால் தான் நம்மளோட ப்ராசஸ் இன்னும் ஸ்பீட் அப் பண்ண முடியும். ஓகே, அப்போ இந்த DMA கண்ட்ரோலர் என்ன பண்ணும், சிபியோட வேலையை இந்த DMA கண்ட்ரோலர் பண்ணும். ஸோ இப்போ சே ஃபார் எக்ஸாம்பிள், if there is a principal in the college, there is a teacher and there is a student. இப்போ 3 பேர் இருக்காங்க வச்சுக்கோ, பிரின்சிபல், டீச்சர் அண்ட் ஸ்டூடெண்ட். இந்த ஆர்கிடெக்சருக்கு நான் சொல்றேன். Principal is like the CPU. Okay, and the next comes your teacher is nothing but your DMA controller and the student. Okay, so in the absence of the principal, now say for example principal is got hold with some other work, she is busy with some other work abhina, he'll give all the power to the teacher. Now the teacher can take the role of the principal, he can act like a principal and he can what to say, he can satisfy all the needs of the students. Appo principal oda edathila the teacher can act. Adha in the DMA பண்ணும். So DMA will take the place of the CPU and it will act like a CPU at some point of time. CPU பண்ற value அந்த இடத்துல DMA controller பண்ணும். Because the CPU got hold with some other work. CPU got hold with some other task இருக்கும். CPU will be busy. So CPU don't want to waste time in this transferring. The data transfer கெல்லாம் CPU இருக்குன்னு அவசியமே கிடையாது. Only if the case if there is some process involved, ஏதாவது ஒரு ப்ரோக்ராம் இருக்கு அதை எக்ஸிக்யூட் பண்ணணும் அப்படின்னா we need a CPU. சும்மா இங்க இருக்கிற டேட்டா தூக்கி அங்க வைக்கிறதுக்கு வந்துட்டு there is no process involved. Right? So we do not need the attention of the CPU. அப்ப என்ன பண்ணணும்? We have to bypass the CPU. So CPU will be busy executing in some other work. ஆனா இடையில ஒரு டிவைஸ் இல்லாம peripheral cannot communicate with the memory. That is very clear. எந்த டைரக்ட் மெமரியிலயோ மெயின் மெமரி கூட எந்த டிவைஸும் டைரக்டா கம்யூனிகேட்டே ஆகாது. Because your system will get corrupted if it is the case. அந்த மாதிரி டைரக்டா கனெக்ட் பண்ணேன்னா your entire system will get corrupted. So I need the help of another device. I need a device in between these two, between the peripheral and the memory. DMA. So for that only there is a controller. So the DMA controller, what is that? Actually it is the hardware. Okay, so what it does, it enables the communication between the peripheral and the memory device. Okay, it facilitates the communication between the peripheral and the memory device. Okay, without the intervention of the CPU, the very very important point in that, without the intervention of the CPU. Why? Because the CPU will be busy executing in some other task. The CPU have got hold in that point of time. Now your CPU will give the control to DMA. Now your DMA will act like a master. In this transfer, your DMA is the master because CPU வந்து யாருக்கு எல்லா கண்ட்ரோலும் எல்லா பவரையும் கொடுத்துருச்சு, DMA கண்ட்ரோலருக்கு கொடுத்துரும். So now your DMA controller will act like a master and your CPU will be a slave. CPU will be a slave. அது பாட்டுக்கு அதோட வேலை பண்ணிட்டு இருக்கனால your CPU will get the role of the slave and your DMA controller will become the master. எப்போ வரைக்கும் மாஸ்டரா இருக்கும்? Only in the particular transfer. அந்த transfer முடிகிற வரைக்கும் தான் your DMA controller is master. And after that again CPU வந்ததுக்கு அப்புறம் கண்ட்ரோல்லாம் யார்கிட்ட போயிடும்? CPU கிட்டே போயிடும். So again your CPU after this entire process is over, now DMA has to give back the control to the CPU. அந்த கண்ட்ரோல் அதே வச்சுக்க முடியாது. So as the principal is out of station, the teacher got the power of the principal as an acting principal. Once the principal returns, மறுபடியும் டீச்சர் அங்கேயே உட்காந்துருப்பாங்களா? No, that is not logically correct. No. So all the powers has to return to the principal again, and the teacher will become the slave. Same thing here. Okay. So CPU இல்லாத வரைக்கும் your DMA controller is the master. Okay, your DMA controller is the master. அது சொல்றத நம்ம கேட்டோம். But once the CPU comes back, அந்த ஒரு வேலையெல்லாம் முடிச்சுட்டு once the CPU comes back, immediately your DMA controller has to surrender all the powers to the CPU again. It has to give all the powers to the CPU, and now my CPU will become the master, and my DMA controller will become the slave. Okay, so அந்த டைம்ல மட்டும் enable ஆகும். The controller will become a master only at that time. Which time? At the time of data transfer between the peripheral and the main memory. At the time of data transfer between the peripheral and the main memory, at that time alone, this particular controller will become the master. Okay, so without the attention of the CPU, your DMA controller will do all the tasks. So அந்த இடத்துல மட்டும் it is the master, and all the other times it will become the slave. At all other times it becomes the slave. Okay, so that's all. Actually, basic logic. If you understand the clear background of it, you can write the theory. Fine. Can I have a doubt in this DMA? Did you understand the core logic behind this? Why we need DMA? புரிஞ்சுதா யாருக்காச்சும் புரியாம இருக்கா? Shall we proceed further? இங்கே எல்லாம் லிசன் பண்றீங்களா? இன்னுமே ரெஸ்பாண்ட் வர மாட்டேங்குதே. What happened? Rajkumar, are you there? Rajkumar, can you hear me? Rajkumar. Rajkumar, did you understand? Are you listening or not? Okay, so yeah, so this is the basic logic behind DMA. Now we move to the theory part. Okay, so now if you read the theory, it will be easy for you. Yeah, theory சொல்லிட்டு explain பண்ணா it will be better boring. So ஒரு லாஜிக் உங்களுக்கு தெரிஞ்சிருச்சு அப்படின்னா அதுக்கப்புறம் அந்த கான்செப்ட் வந்து உங்களுக்கு புரிய ஆரம்பிச்சிடும். Okay, so your DMA is nothing but it is a feature of your computerized system that allows certain hardware systems to access the main system memory independently of the CPU. And the word is very important. Independently of the CPU means we do not need the CPU to do that operation. Okay, so that is the Wikipedia definition. We don't want that. We came to this one, which is very clear. See, direct memory access. Direct memory access, DMA. It is a means of having a peripheral device. It controls to the processor memory bus directly. Process memory peripheral device டைரக்டா வந்து என்ன பண்ண முடியும், கண்ட்ரோல் பண்ண முடியும். அதுக்காக யூஸ் பண்றது DMA. So DMA is a mechanism through which the peripheral device can directly control the processor's memory bus. Actually அது ப்ராசஸரோட மெமரி தான். மெயின் மெமரிங்கிறது ப்ராசஸரோட மெமரி. அதனால தான் இந்த ப்ராசஸ் மெமரி பஸ்ன்னு சொல்றாங்க, வேற ஒன்றும் இல்லை. So your peripheral device can control the processor's memory bus directly. Processor's memory bus directly. So that is called what? That is called as your DMA. Okay, so when you get into this, this is the appropriate definition. Now we get into the technique. See, DMA is nothing but it is a technique which provides direct access to the memory while the processor is temporarily disabled. Temporarily disabled while the processor is busy in some other task. Matta task temporarily disabled it will be busy in some other task practically. Okay, so at that time, while your processor is busy in some other task, at that time you can use this particular technique. Which technique? DMA technique. It is an input-output technique through which you can directly access the memory. That is very, very important. Okay, so all the IO devices are connected to the system bus via a special interface circuit called DMA controller. See, connect பண்றது. I have an IO device here. Okay, I have a memory here. இதுக்கு இடையில இருக்கிறது அந்த பஸ். You have system busனா ஒன்றும் இல்லைன்னா data bus, address bus and control bus. இதுதான் வந்து சிஸ்டம் பஸ்ன்னு சொல்றாங்க. நீ ஏதோ புதுசா வந்து நினைச்சுக்காது, நம்ம ஆல்ரெடி பார்த்ததுதான். டேட்டா லைன், அட்ரஸ் லைன், கண்ட்ரோல் லைன், 3 சொன்னேன். 3 lines are there. It is a bus. It is nothing but group of 3 lines. இதெல்லாம் படிச்சிருக்கோம், ஞாபகப்படுத்தி பாரு. So a bus is nothing but it is a group of communication lines. So how many lines are there? We have 3 lines. One is data line, another one is address line, another one is control line. ஓகே ஸோ இது மூணுமே மெமரி கிட்ட இருந்ததுன்னா அது மெமரி பஸ்ன்னு சொல்லுவாங்க, ப்ராசஸர் கிட்ட இருந்ததுன்னா அது ப்ராசஸர் பஸ்ன்னு சொல்லுவாங்க, ஐஓ கிட்ட இருந்தால் அது ஐஓ பஸ் அவ்வளோதான். ஸோ இஃப் ஆல் த 3 lines are there attached to the memory, I can call it as memory bus. If all the 3 lines are attached to the memory, I can call it as memory bus. Okay. So okay, with this I'll stop here, and the afternoon session will continue with this direct memory access, which is very very important question. It is there for your internals also. This DMA. Okay. So it is very important. So listen carefully. Take the screenshot. You have a block diagram also. You need to draw the block diagram also. Whenever it is asked, you need to draw the block diagram appropriately. Fine. So we'll continue in the afternoon. Okay. Any doubts so far? Any doubts? We'll continue the DMA in the afternoon session. Fine. Kana, do you have any doubts in this? Yes or no?
No, ma'am.
Reply. What happened? Okay, Kana. So in the afternoon class also, please join by time. Don't delay. We need to complete 2 topics actually. Once we completed now, 3 units will be completed exactly. Because all the things are asked in the question paper also. So please join and on time, okay? Don't delay. Fine, Kana. Thank you. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you.